Hello students, welcome to this lecture number 10. In this lecture, we are going to discuss the Bohr atomic model. This is a very important topic in this chapter that you must learn this totally because from this chapter we are going to there will be a lot of numericals and conceptual questions may come. In the year 1913, Niels Bohr was the first scientist to give a detailed feature of the hydrogen atoms and its line spectra. Previously, in the view of the shortcomings of the Rutherford model, Bohr has put forward a very important, very improved versions of the atomic model, which is called the Bohr atomic model. Basically, he has adopted two things in his model, that is the development of the recent times at that time, that is the real nature of the radiations, number one, and number two, the quantized electronic energy that is capable of explaining the line spectra of the hydrogen. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Today we are going to discuss these postulates of the Bohr models. That is the postulates of the Bohr model we will going to discuss. The first postulate, this is the first postulate. You can see in atom, electron revolves in a concentric circular path and it is called the orbit. So definition of the orbit is been given by the Bohr in his first postulates. This is the second postulate, that the energy of the orbit is specific and definite, and it is called the energy level, stationary state, allowable energy level, and represented by n. It is represented by n. N is 1, 2, 3 and it can take up any value up to infinity. And alphabetically it has K, L, M, N, O, P. It will be going as the numbers. Why it is called in stationary state? Because when the electron revolves in this orbit or in the stationary state, it will not going to emit any type of energy. And you can see that is the failure of the Rutherford model, that he could not able to reconcile these things. That is why he failed, because when Maxwell comes, Maxwell say that the particle having the charged particle when revolves means it is accelerated, it will emit energy. But Bohr says it will not going to emit the energy, and that is his postulate stands to explain the stability of the atom. So this is the second postulate. Third postulate is this is a third postulate. It says the number of electrons in a orbit will be 2n square, where is n is the number of the orbit. When first number orbit, it will have the 2 electrons. Third, it will have the how many electrons? That is first, second, that is your 2 electrons. Then when it is second, this will be into 8 electrons. Third, it will be 18 electrons, and like this it will go on at accommodating number of electrons. Okay, this is the third postulates. Now we are going to have the fourth postulates. It is about the energy. The energy of the nth orbit that is given by this formula. The energy of the nth orbit is this 2 pi square m e to the power 4 z square. Z is the atomic number, h is the Planck's constant, n is the orbit number. And when we put all these constant term, because there is a constant term here, you can see this is the mass of the electron, the charge of the electron, that is Planck's constant. Those are all constant. So when we put this constant, this equation will be like this. So you can see after putting the constant value, you have that different expression, and this expression is different because of the different units. This is when 21.8 into 10 to the power minus 19, it is in the joule per atom. 13.6, it is in the electron volt, and it is in kilojoule per mole. So in the numericals, you will face this type of things that are necessary for you to remember. Sometimes it is expressed in electron volt, energy is expressed in electron volt, sometimes it is in the kilojoule per mole. So accordingly you have to remember this. So we understand what is the energy of the nth orbit, and this is given by this. And what is the things that you can see, there is a minus, negative is given in the energy term. Why it is so? Let us first understand. This is because it represents one thing, that when the energy of the stationary state is minus, means it is any allowable energies levels, that is any allowable, that is orbits will have the less energy as compared to the energy of the electron, which is free, which is at the infinity. Right? Any energy level. Suppose this is a nucleus, and this nucleus there is a orbit, and in this orbit you can see there is a L number. Suppose this is 1 number, it is called K. This is 2 number, it is called L. Accordingly you can see, and the energy of this stationary state will be lower than the energy of the electron at the infinity. And what will be the energy? Energy, you can say, by putting this infinity, n equal to infinity, we get the energy, that is energy of the electron at the infinity, when there is no attractive force on this electron. So this will be a 0. This will be 0. When this is 0, and the maximum energy of the electron can have, then when the other energy of the other stationary state, that must be lower than this 0, And if it is lower than the 0, then you have to put a minus sign to it. And you can see, as from this formula, that energy of the orbit is inversely proportional to the n square. Means as we goes on decreasing the n, what is going to happen? The energy term will be much more negative, because it will, when the denominator is decreasing, means this value will be increased, and it will have a very high negative value, means this energy will be very less. So energy of this level, that's the first level, that is first orbit, will be least, and it is called the ground state. Second orbit will be have the higher energy than the first. First having the lower energy than the second, and it will continue like this way. Now this expression is helpful when we are talking about the hydrogen atom. For the hydrogen atom, we know Z equal to 1. Then this energy will be energy of the nth orbit will be minus 21.8 into 10 to the power minus 19 into J is 1. So divided by n square. So when we put the value of 1, we will get the energy of the first orbit. We will get the value of the n is 2, we will get the energy of the second orbit. So we will continue to get the energy of the different stationary state. And this energy, this formula will be applicable also for the hydrogen-like species. Hydrogen-like species means the species which is having the one electron in their orbit, like He plus, like Li2 plus. All those species, ions, you will find, cations, you will find there is a one electron in their orbit. So when we apply this formula, we just apply the formula with Z value will be different. For the helium plus it will be 2, for the lithium plus it will be 3. Accordingly, the energy of the stationary state of that atom will be changed. Okay, so we understand the energy and this correlation with your number of the orbits and the correlation with the Z also. Z means the atomic number. Higher the atomic number, lower will be the energy, and it will, the electrons will be bounded at the most at the levels. Okay. This is the fifth postulate. In this postulate, we will discuss the radius of the orbit. Radius of the orbit, or we can say it is a stationary state. That is, suppose this will give orbit, the radius of nth orbit. So the fifth postulates about the radius of the orbit. The radius of the orbit, you can, nth orbit is given by this formula, n square h square divided by all these terms. And when we put the constant terms of this formula, it will be coming around this 5.29 into 10 minus 9 n square by h. If we put the another units, it will be picometer, 52.9 into n square by z. Now for the hydrogen atom, we know Z equal to 1, and when n equal to 1 means that is the radius of the first orbit, it is coming around radius of the first orbit R1, suppose it is give 52.9 in n, and this is called also the Bohr orbit. Bohr orbit. Okay, this is also called the Bohr orbit. So when we are putting this value of n equal to 2, we will get the Bohr orbit accordingly. And this formula is also applicable for your hydrogen-like species. At that time, you have to utilize this information. What is the Z atomic number of this, and what is the n of this, which first orbit or second orbit, third orbit we want to calculate. So this is the radius of the orbit, and this is like this. And you can see one thing, radius of the orbit is inversely proportional to the atomic number. When atomic number is increasing, is radius will be decreasing. That is means when we are taking about the hydrogen atom and when we are taking about the He, hydrogen species, He plus, what we found, the radius of the He plus will be less, that's the first orbit of the radius, than the hydrogen's first orbit radius, because of this Z. Because of this Z is higher in this case. Okay, so we now understand what is the radius of the orbit. Now the sixth postulates, this is again a very, very important postulates, that is about the angular momentum. As the electron is revolving around the nucleus, so it will have some angular momentum. And what will be the angular momentum? As per Bohr postulates, it will be n into h by 2 pi, was n is equal to 1, 2, 3, and it will take up n value. Okay. So from this statement, we can able to draw a conclusion that electron can only be in that orbit in which the angular momentum will be integral multiple of this h by 2 pi, and this is a very, very important that we must remember. Thus n into h by 2 pi will be the angular momentum, and it is fixed for a particular orbit. Second postulate, that is the electron can only emit or absorb a fixed quantity of energy. So that is called quantization of the energy. Eighth, that is the velocity. About the velocity, what will be the velocity of the electron as it is revolving in this circular orbit? Velocity is given by V, and its formula is velocity of this electron in the orbit. It is coming to 2 pi z square by nh, and you can convert this into constant term. This is 21.8 into 10 to the power 8 into z by n. So here velocity, you can see it is directly proportional to the atomic number, and it is inversely proportional to the n. So at the velocity will be the highest when it is the first orbit, and it will goes on continuously increasing. The 9 postulates that we are talking about, that is the very important thing, when the energy of the electron so energy is not going to change when it is in a same orbit. But when it comes from one orbit to the other orbit, its energy is going to change. At that time, it will whether it can absorb energy or it can emit the energy. When this energy will be emitted, it will be in the form of the electromagnetic radiation, and depending on the energy difference in the energy level, that is E2 minus E1, it will be given the H nu. H nu is the frequency of the electromagnetic radiation, and this value is called, this equation is called the Bohr frequency equation. Bohr's frequency equation. So we can understood the postulates of the Bohr model. It is a very important model. The first model which gives a quantitative analysis of the electrons of the atoms, like its energy, like its radius, like its velocity, all the things that has been given. But it has a lot of positive points, that it able to give explanation of the stability. It able to give the explanation of the line spectra of hydrogen. But there is also some drawbacks. Shortcomings of his model: number one, for the finer aspect of this line spectra, that when line spectra is being analyzed under a sophisticated spectroscopy, there is a splitting of the line you can observe. Number two, this energy, this electron model, this atomic model will applicable only for the hydrogen. So when the line spectra of the complex electron, complex atoms, that has not been explained by this Bohr model. Third thing, that is the Zeeman effect and the Stark effect, that when the splitting of the spectral line in the magnetic field, it is called the Zeeman effect, and it is Stark effect is when splitting of the magnetic in this electric field, that is not been able to explain by the Bohr model. Another thing, that Bohr considered atom as a planar structure, but it is a three-dimensional structure. And fourth thing, that he could not able to explain, either could not able to include the recent development, that is the dual nature of the matter and Heisenberg uncertainty principle. And in this way, Bohr model is a very good model, there is no doubt, but it needs some improvement. That we are going to discuss in the previous video. That first we will discuss the uncertainty principle and the wave nature of the dual nature of the matter, and then we will discuss the quantum mechanical model of the atoms afterwards. And that is all for today's video. If you enjoy this video, you can share with your friends. Thank you very much for listening. Thank you.